Okay, so now I'm going to trick it. Now I am going to send something up. Aha, I just typed in some characters. Now what? Well, it's just going to hang now because I'm not calling next or anything. So it's just going to sit here. But it didn't break. So our protect middleware isn't good enough yet. I bypassed it by just typing in some random strings. So we're not there yet. We checked to see if it was there. That's great. But now we got to check to see if it's real. And that will stop this from happening. So let's go do that. So now what we'll do is we'll go check to see if this is actually real or not. So the way we'll do that is we'll grab the token off the bearer and check to see if there's an actual token. And then that'll be another check. So let's do just that. Let me go to auth. Next check would be, let's just say const. I'm gonna destructure here. So I'm gonna put an empty array for now. And I'm gonna say bearer dot split on an empty space. The reason I'm splitting on an empty space because I'm saying you need to send me a token that looks like this. And you should say bearer space and then your token here. So I'm splitting on this empty space, which is gonna, and split returns an array. And it should have the word bearer in the first argument, in the first index of the array, and then the token in the second index of the array. That's what split's doing. So that's what I'm saying is the API creator. That's what I want you to send me. So that means the first thing here is the word bearer. I don't care about it, so I'm just gonna put comma. But the second thing is a token. I care about that, so I'm gonna say token. So now we have a token. Then I can say, oh, if not token, you already know what's about to happen. I'm about to give you the same thing I gave buddy up here. It's a 401 and not authorized, like, or I can say like, not valid token, or whatever I want to put. Okay, so to test this, stop our server, start our server, go back to Thunder client. This was able to fool it last time. Let's see if it fools it this time. I think it still fooled it. So we're not there yet. We still haven't built a sophisticated enough protect to stop something as trivial as just typing in something here and hitting send. So not quite there yet. It's still hanging. I'm guessing the split actually created, well, yeah, if you split on empty space with nothing in it, it's still going to just give you back the string. So it's still going to bypass it. The split's not good enough yet. So now what we want to do is we want to like, okay, cool, you got past here. You sent up a token. You actually formatted it correctly somehow. But is it a real JWT signed by this secret? That's the last check. So if you can get past that, then you must be real. Or you stole someone's JWT, which means you're real. So let's do that. Let's go back to our code. And we'll say, okay, cool. We're going to try catch this because it could break. And if it breaks, we don't want the server to break because you like this method from JWT will break if it doesn't verify, but we don't want someone sending a wrong JSON Web Token breaking our server because the user messed up. We don't want the rest of our users suffering because someone like tried to authenticate incorrectly. Like imagine someone's server crashing because you forgot your password. Like that's the equivalent of this. Like I don't want that to happen. Like, oh, someone forgot their password and that crashed the whole server for everybody. Like that would be terrible. So that's why we're try catching this. Okay, so now let's say const user equals JWT dot verify. So we want to verify this token with this secret. So process.env dot JWT secret. So we're going to get this token. And then if not user, right? Or there we go. I'm just going to assume that it is. So we got that. Otherwise, this would actually break. So then I'll just say rec.user. I've augmented the request object equals user, which should be the object that we signed all the way up here. So it should be an object with an ID and a username because that's what we signed into existence. And then I can say next. I'm done. Not next tick, but next. And I guess I need to put next here because it is a middleware. If any of that breaks, you know what we're doing. We doing this. We're coming over here. We're saying no. And I'm just gonna log the error just so we can see it. So we're gonna try to verify this token with this secret that we signed the token with. If it is a user, we'll attach it to the request object and we'll call next. So anything in the stack can now do rec.user and see the user who's currently making the request. They can identify them. It'll have an ID and a username on it. Perfect for querying the database. Otherwise, you know what's gonna happen. You get that 401. So let's give it a go. So I think this one is still, wait, do I have? I will say this one's still gonna hang because I don't have any handlers, but we do have a handler in, where is it? There we go, for get/product. So I gotta make sure I go there. Okay, so let's try this. Let me start it again. And now if I try to do this and I run this code, boom. Now our spoofing JWT that got past those 2 steps are no longer gonna get past that last step because it's not a valid token, right? And we can go look at the error that the JWT logged. You can see right here, JSON Web Token error, JWT malformed. This didn't break the server though because I caught it. If I didn't catch this, if I did not wrap this in a try catch, our server would be off right now. It's still on. It's still on right now. But if I didn't do the try catch, it would be off. And everybody would be tweeting us because our server died in the middle of a ranked game or something like that. Something weird. So, any questions on that? That was a lot. Authentication's tough. And it gets tougher than this. But for the most part, it's mostly just this. Plus other stuff. Yes?
Would API rate limiting be also implemented in a middleware?
Good question. So API rate limiting is a mechanism you would use for an external facing API. So as in your product is an API. Again, I hate to use Stripe again, but Stripe's product is an API. Their product is documentation. So they would have something like rate limiting because they don't want one person killing all their, like somebody could just write a script on an infinite loop and deploy it to like, 30,000 IP addresses and just like try to bring down your server. They don't want that to happen. So they implement something called rate limiting, which looks at an IP address and limits how many times an IP address can make a request per second before it gets blocked for X amount of time before they're allowed to do it again. Yes, you could do that in the middleware, but for more performance, you don't want that. You don't want that request even reaching your server because, yes, you stopped it from reaching the handlers, which talk to the database, which are the biggest performance hit, but it's still on your server and taking up resources there. So typically, a rate limiting for a more sophisticated API would probably be added before the API. So technically, it is kind of like middleware, but like middleware on the network layer and not on the code layer. And this would be like a proxy or an API gateway or something like that, which is another server that sits in front of your server. And that server does things like rate limiting and access control. So that way your server can safely make the assumption that this request is safe and ready to go. And that's just a whole nother thing. There's literally products that are just that. Okay, everybody's an auth expert now?
No.
Auth's tough. Okay, but at least we're protecting our routes now. You can't access any of these routes. They're good to go. It's cool.